With question 11, what strikes me most is there is a tangent. Now when there's a tangent on a circle, you've got two possible theorems. The first one is going to be the tangent and the radius form 90-degree angle, but there's no radius marked here because a radius would come from the centre of the circle and there's no centre. So if it's not the tangent and the radius form 90 degrees, it must be the alternate segment theorem. The alternate segment theorem says, effectively, if we take our tangent, which I'll draw in red, and then we have a chord coming off it that forms an angle, so that we'll take it on this side since that's the angle which is given as 56 degrees. So that angle there between the tangent and that chord is exactly the same as the angle, any angle made from that chord. So that chord goes from A to D, so that 54 is the same as any angle drawn from A to D, so it's the same as this angle up here. Those two angles are the same. The reason it's called the alternate segment theorem can be seen if I just block out that part of the circle. Here we've got the minor segment, and there's an angle between in the minor segment and the tangent. And then if I block out the other part, we see now we've got the major segment, and this angle here in the major segment is, no matter where it goes, is always going to be the same as that angle there between the minor segment and the tangent. So this angle up here is 54 degrees. Let's see what the question actually goes and asks though. It asks us to find the size of angle ACD. So that's quite a straightforward one. It is actually from A to C to D. It's the one which I was talking about, so that's 54 degrees. So there's the answer and there's the reason. The angles in the alternate segments are equal. Part B wants us to explain why BD is a diameter of the circle. Well, if BD is a diameter, then the angle formed from that diameter will be 90 degrees. So let's have a look. BD, that's from B across to D. So they're saying, why is that a diameter? Well, it means that any angle from B to the circumference and back will be 90 degrees, if it is a diameter. And true to form, yes, because there is 36 and 54, they add up to 90 degrees, and the only time that happens is, like I said, is if that BD was a diameter. So that's what I've put. Explain why BD is a diameter of the circle, because the angles at C add up to 90 degrees. The 54 plus 36 equals 90. The last part, part C of the question, says work out the size of angle ABC. Sorry. So ABC, let's see where that is on the diagram. From A to B to C. So from A to B and then to C. Well, that forms 3 points on the circle, and we can go and make our quadrilateral by joining those to the fourth. So we've got a cyclic quadrilateral here, and the angle we want here is opposite this 78, so our answer is going to be 180 minus 78, and that's 102 degrees. So that's what I put here, 102 degrees, opposite angles in a cyclic quadrilateral add to 180. Question 12, this has a tangent in it. PA is a tangent. It's not linked up to a radius, so it's not tangent and radius make 90 degrees. It must be the alternate segment theorem. So if this is our tangent there and it's making an angle with this chord, then if I draw another angle from this chord, from AD, that's going to be angle B. So this angle here is going to be the same as the angle between the chord and the tangent. That's what the alternate segment theorem says. Let's just read what the question goes and asks us to find. it says calculate the size of angle ADB. ADB. So if I do that in green, it asks us ADB, so it's going to be this one, that one, in there, in green. Now I know from the alternate segment theorem that this one was 39 degrees. If I can find out what this blue angle is, then I've got a triangle and I can just add those together and take it away from 180. Unfortunately, this blue angle we can find because that blue angle is part of that cyclic quadrilateral. So the blue angle there must be 180 take away 103 degrees, because opposite angles in a cyclic quadrilateral add up to 180, so that's going to give us 77 degrees, so that's 77 degrees. So now I can find the green angle. The green angle there is going to be found by doing 77 plus the 39. That's going to make 116 degrees, and so all the angles in the triangle, 180 take away 116 is going to give it a 64 degrees. Question 13. Again, there's a tangent in here. We've also got this shape here, which is well, it's nothing to do with the tangent, so I'm just going to focus on the tangent here for now. This tangent here, it's not linked to radius, so the tangent radius don't make 90 degrees, so it's the alternate segment theorem. So this tangent forms an angle with this chord here. That's the one we're given here, so that's 47 degrees. So if I take this chord, which makes the angle, where's the angle that comes from there? It's this one up here, isn't it? So it's this angle up here is going to equal this angle here, so that's 47 degrees. Now I've automatically filled that one in without even considering what the question goes and says. Let's read the question now, see what we're expected to find. Find the size of angle AED. AED. So that's A up to E and across to D. So that's this angle here. Well, I suppose that actually forms a triangle, doesn't it? I don't know if that's helpful or not. It forms a triangle with this line here, and we know that's 56. So if we can find out this angle here, we'll be able to work out that one. I've had a look at this one, and I think finding that's quite a tricky one, but something I did spot, which makes this question actually very easy to start with, is there were little arrows on this line here, and there's an arrow on this line here. Now those arrows mean that this line here is parallel to this line here, and since this is a crossing line, we get a pair of alternate angles. This green angle here is exactly the same as this angle of 47 degrees there, because they're alternate angles. So that angle is actually 47 degrees. So there's the answer there. It's 47 degrees because alternate angles are equal. The next part of the question goes and asks me to find the size of angle BCD. With BCD we have this angle, and it's 3 points on the circumference, and we can actually join it to a fourth point here to get a cyclic quadrilateral. And as you know, in a cyclic quadrilateral, opposite angles add up to 180 degrees. So this is 56. So C, this angle up here, must be 180 take away 56, and that's 124 degrees. So that's that. If we look at the next question, it says find the size of angle ADB. ADB. So from A to D to B, that's the angle I've already found actually with the alternate segment theorem, isn't it? Because that angle there from that chord is the same as the angle from that chord and the tangent. So that's 47 degrees, and it's because angles in alternate segments are equal. With question 14, there's actually two tangents, but this time the tangents are forming an angle with the radius. This is a radius because it comes from the centre to the outside of the circle. So that means a tangent and the radius, that's going to be a right angle there, and this is going to be a right angle there. Let's have a look what the question goes and says anyhow. It goes and asks us to calculate the size of angle APB. So APB, start at A, go up to P and end up at B. It's this angle here. This angle in here is the one that we're hoping to calculate. Now this is a kite. That's a quadrilateral. And we know the angles in a quadrilateral add up to 360 degrees. We know that's 90, that's 90. If we know what that one is, we can work out that by taking it away from 360. This one is straightforward to work out because it's an angle at the centre, isn't it? There's a dot marking the centre, and that's the angle at the centre. So the angle at the centre is twice the angle at the circumference, and the angle at the circumference is this one. So this one is 2 times 76, which is 152 degrees. So that's 152 degrees, so that means these angles add up to 152 plus 90 plus another 90. That comes to 332, and so angle P is going to be 360 take away the sum of those three angles, and that's going to come to 28 degrees. Right, question 15, again it's got a tangent, it's also got a diameter in there. What's the secret one here? Well, in fact, the secret here is noticing that this tangent, it's not joined to a radius, and it's not making an angle. I mean, I could extend this if I wanted to, and I'd get an angle with that line, which would potentially give me the alternate angle theorem. But what I'm going to do, I'm actually going to draw, I've got the centre there, so I'm actually going to draw the radius in there, and if I draw the radius in there, that is 90 degrees. Another thing I can work out is because this is one radius here and that's one radius there, then this angle at the end here and that angle are the same, so that's 21 degrees. I could carry on doing more, but I'll leave it like that. I'll just go and check what the question wants. It says work out the size of angle APC. So APC, from A to P up until C. So it's that angle in there that I want. Well, in fact, I'm just going to use this big triangle that I've drawn in green. I'm going to join it up there. This angle there is 21. With my doodlings earlier, this is going to be 111 if I do 90 plus the 21, so that angle there is 111 degrees. So 21 plus the 111 makes 132. So since this is a triangle, APC, the missing angle, must be 180, take away the 132, 48 degrees. And if you notice here, it's worth a total of 4 marks, and it's important then to actually show this working out and even the lines on the diagram, otherwise you won't get the marks for working. With question 16, and we've got this line coming through here. Now that's not a tangent, so we can't do anything like, but this one is a tangent. This tangent line here is not making an angle with a radius, so it's not the 90 degrees between radius and tangent, it's the alternate segment theorem. Now the alternate segment theorem says either this angle here is going to be equal to this angle there, or if I do the other side of it, it could be this angle here is equal to that angle there. There's always two sides to the alternate segment theorem. You might need both of them. But this 44 degrees, notice, is not the whole angle, it's just part of it. I'm going to read the question to see what I need to find out. Question says, work out the size of angle STU. STU. So that's actually from S to T to U. So in fact we only want this little bit of angle in here. Okay? We know this bit, well, that's the alternate segment theorem in fact. I'm going to first of all work out this whole angle, and then I'm going to take away 44. Now this whole angle made between this tangent and this chord, that's the chord that angle is on, and the other angle on the other side of the chord is up here. So this angle here is equal to that whole angle there, but this angle must be 180, take away 108, so that's going to be 72 degrees. So if this is 72 degrees, then this whole angle here must be 72 degrees. So this little bit in there is going to be 72 take away the 44, which gives 28 degrees. Now the question goes and says also here, you must give a reason for each step in your working. So I've got to go through every calculation that I did and just explain. It's worth a total of, let me look down here, 5 marks.